Okay, so looking at D, E, and F, you follow the same pattern as the earlier problems, but looking at G through K, notice that your inside function is not the arc one, but it's the outside one. So here, if the functions are the same, you can cancel them out as long as the angle is within the restriction. Remember, inverse cosine is between 0 and pi, so pi over 2 is between 0 and pi, so I can cancel them out, getting pi over 2. Inverse tangent is between negative pi over 2 and pi over 2, and pi over 3 is between those, so I can just cancel these out, getting pi over 3. But right here, right, if I look at the following, inverse sine needs to be between negative pi over 2 and pi over 2, but this is 3 pi over 2, which places you like over here, right? So that's not okay. So I have to take a look at this more closely. So for these problems, I suggest you do the following. Look at the inside. What is sine of 3 pi over 2? Sine of 3 pi over 2, you look at your unit circle and you see that that's really negative 1. So now you have to find arc sine of negative 1. What is arc sine of negative 1? Where is your y value equal to negative 1 in your unit circle in the correct restriction here? And that's going to be right here, which is negative pi over 2. So you're rewriting 3 pi over 2 as a coterminal angle in this case, right, to get the same answer. Final answer is negative pi over 2. Looking at J, arctangent of tangent negative pi, I notice that negative pi is not within my restriction of negative pi over 2 to positive pi over 2 for arctangent. That means I have to go look at the inside first. What is tangent of negative pi? So tangent of negative pi is over here. That's negative 1 comma 0. Tangent is y over x. So y over x would give me 0. Okay, from negative pi over 2 to pi over 2, on your unit circle, where do you get tangent ratio of 0? Where do you get y over x equaling 0? And that's only going to be at 0 radians. 0 radians gives you 1 comma 0, and y over x gives you 0. Right? So positive pi over 2 and negative pi over 2, they would give you undefined, as well as they're outside of your restrictions anyway, so you couldn't have those as your answer. So final answer for J is 0. Looking at K here, we see that we have arc cosine of negative pi over 2 going on, or arc cosine of negative pi over 2. Negative pi over 2 is not within the arc sine restriction of 0 to pi, right? Remember that this could also be written as inverse cosine of pi over 2, negative pi over 2, because inverse cosine and arc cosine are two different ways of writing the same thing. So that means we have to figure out what cosine of negative pi over 2 is. Well, cosine of negative pi over 2, that's at 0, negative 1, is 0. So you're thinking arc cosine of 0. What is arc cosine of 0? That means where does x equal 0 going from 0 to pi? So you look at your unit circle, you look for the place where you have an x coordinate of 0 in this region, and that's going to be at pi over 2. So pi over 2 is your final answer, right? At pi over 2 you get 0, 1. So you get an x coordinate of 0. For these problems here, using the properties of inverses, evaluate the following. So notice that these are different from the ones that we were just doing earlier because the functions are not the same, right? They're not just inverse functions of each other. So for these, you need to draw a triangle in the correct quadrant. So let's take a look at the following. We have arc sine of 3 over 5. So arc sine means our answer has to be either in quadrant 1 or quadrant 4, since that's where the restrictions are for arc sine. But because it's positive, our answer will be in quadrant 1. Opposite over hypotenuse, or y over r. This is a 3, 4, 5 triangle. So we can fill that out. It's positive x-axis. Secant, right? It's reciprocal of cosine. So instead of having adjacent over hypotenuse, it's going to be hypotenuse over adjacent. Right, in quadrant 1, cosine is positive, right? All students take calculus, therefore secant is also positive. Or you can just look at, right, looking at the x coordinate, it's positive x. Let me just kind of get you started for B and C, and I think you can figure it out from there. So arctangent of negative 12 over pi. So arctangent means you have to either be in quadrant 1 or quadrant 4, but because it's negative, we're going to be in quadrant 4. And it's opposite over adjacent, or y over x, therefore it's going to be negative 12 over 5. It's a 5, 12, 13 triangle, so here we have it. It's positive x, right, in quadrant 4, and negative y. Also remember, cosecant has to do with a sine, and in quadrant 4 it's negative, so our final answer is going to be negative. So you go from there. Right here, arc cosine is between 0 and pi, but because it's negative, we're going to be in quadrant 2. Adjacent over hypotenuse, you're going to have to use Pythagorean theorem to see that this value is going to be square root of 5 and go from there. Okay, let's look at the calculator portion. All answers should be rounded to 3 decimal places. Number 1, it says to convert to radians. So it's given to you in degree and minute. That's actually a minute, but it got cut off. And you have to convert to radians. So when you're just doing conversion, it doesn't matter what mode you're in. It's when you're doing things like cotangent and cosine that you need to be in the correct mode. Okay, so it doesn't matter what mode you're in. What you do is you do 52. Then second apps gets you angle, and option 1 gives you the degree symbol. Then hit enter, and then you put 12, you type in 12, you do second apps, which gives you the angle option, and hit 2, which gives you the minute. And when you hit enter, you should convert 52 degrees 12 minutes into 52.2 degrees, because that's giving you 52.2 degrees, or equivalent forms. Just as a reminder, what you have is when you have minutes and seconds right here, minutes and seconds, what you're doing is you're splitting a degree into 60 subunits. So if you have 1 degree, if you cut into like 60 even pieces, even like smaller pieces, that gives you 1 minute. And then if you have that one piece, if you cut it into 60 even pieces again, that gives you 1 second. So these are just like smaller components of that 1 degree angle measure. So once you have 52.2 degrees, which is equivalent to 52 degrees and 12 minutes, you want to convert to radians. And the way that you convert to radians is you have your 52.2 degrees, and then remember you're just going to multiply by pi over 180, right? Because that's the conversion factor, right? So if you get that, and you round to 3 decimal places, it's going to be 0.911. For number 2, you're just converting to decimal form. So here, you don't have to convert to radians, you're only going to convert to decimal form. So you do the same thing. You put 280, second apps 1 degree. You put 8, then second apps 2, which gives you minutes. And then when you do 50, to get that degree symbol there, it's going to be a little bit different. What you'll have to do is after you hit 50, do second plus, because it's at second plus that you'll see that minute symbol there. Hit enter, and then when you enter the whole thing, you will get about 280.147. So for this problem here, convert to degrees, minutes, and seconds, we're going backwards. You're given an angle measure in degree, but in decimal form, and you have to convert that to like degree minutes per second. So you type in 85.36, and then you go to second apps again to access the angles menu. And if you look at option 4, it says change to DMS, like degree, minute, second. So you just hit enter, enter again, and you will get the answer of 85 degrees, 21 minutes, and 36 seconds. Going over number 4, evaluate each of the following. Make sure you are in the correct mode. So anytime you're doing sine, cosine, tangent, or if you're doing trig functions of angle measures, and it matters what unit you're in, right? Because it matters if you're doing calculations in degrees or radians. So remember that if you don't see a degree symbol, right, then that means you're in radians. Okay, so these are all in radian mode, and then these are in degree. So I would do like all the radian ones first, then convert back to degrees, and then do everything else in degrees. So a couple things to note if you have like cotangent or cosecant or secant, the way you're going to write this is 1 over tangent of 2.3, right? Because that's an angle there. And then for cosecant, you're going to have to type 1 over sine of 105. For secant, it's going to be 1 over cosine of 54 degrees and 7 minutes. And then you hit enter, rounding to 3 decimal places.